am Dr.Subhashree from PG Physics Department. In this session, we are going to discuss about the microcontroller and the special features of microcontroller 8051 and its architecture. Here, we are going to discuss about the basic introduction and the difference between the microprocessor and microcontroller and the various microcontroller families, and the main thing 8051 pin configuration and 8051 architecture. This is the layout for this session. This slide shows about the difference between the microprocessor and the microcontroller. Here the microprocessor is the central processing unit which is existing in a single chip for a microcomputer, and the microprocessor has no read-only memory, random access memory and input-output port, right. These features are interfaced as a peripherals as in the case of microprocessor, and in the case of microcontroller the random access memory and read-only memory and input-output ports are altogether as a built-in function within a single chip. So this microcontroller, all the things are embedded in a single chip, so it is also known as embedded system or a standalone system. But in the case of microprocessor, it requires more external storage because all the special features are connected as a peripherals, so it requires more external storage. And the microprocessor is a general purpose. The hardware design also can be modified based on the application demands. But in the case of microcontroller, it does not require much additional interfacing because all the special features are inbuilt together in the microcontroller. So it is known as embedded controllers, and it has a clock speed with a range of few tens of megahertz microcontroller, which is the main thing for many applications. This block diagram shows the special features of the microcontroller. These are all the blocks which is inbuilt together within the microcontroller chip. Arithmetic logic unit and mainly the accumulator and special function registers, then internal random access memory and the stack pointer, internal read-only memory and various timers and counters and the program counter and all the clock circuits, interrupt circuit and input-output port. These are the special features in the microcontroller, and all these blocks are inbuilt together in a single chip. This diagram shows the various microcontroller families. Here the microcontroller, at the time of invention, the microcontroller was invented as a 4-bit microcontroller, and later it was developed as a 8-bit microcontroller and 16-bit and as well as 32-bit. So basically in the 4-bit microcontroller it has 4 data bus, and in an 8-bit microcontroller it has 8 data bus. And when compared to the precision and speed, 8-bit microcontroller has higher speed rate than the 4-bit microcontroller. Similarly, in the 16-bit microcontroller, it has higher speed rate than the 8-bit controller and vice versa. And in the case of memory devices, embedded and external, these two categories are based on the memory and devices. When it is a external memory means all the functions, all the special functions as we have discussed earlier in the previous slide are connected as a peripherals. As in the case of embedded system, all the special functions which is shown in this block diagram are connected as a inbuilt. All the special functions are inbuilt together within a single chip as in the case of embedded system, but in the case of external memory, specifically the read-only memory and random access memory can also be connected as a peripherals. And the instruction set in the microcontrollers, complex instruction set computer and reduced instruction set computer. The memory architecture can be categorized as Princeton and Harvard architecture. The several companies are manufacturing several microcontroller families, particularly in Intel they are manufacturing 8051, and the several companies are manufacturing several microcontroller chip as shown here. This shows the types of microcontroller and its families. Basically, it is classified based on the internal bus width, architecture, memory and instruction set. Here, we start with the 8-bit microcontroller. Since 4-bit microcontroller is comparatively very slow and it has a 4 bit data bus width, and it is comparatively very slow as in the case of 8-bit. So here we are starting with the 8-bit microcontroller. When the arithmetic logic unit performs arithmetic and logical operations on a byte, which means 8-bit calculation, at any instruction, the microcontroller is an 8-bit microcontroller. So the internal bus width of this type of controller is 8-bit microcontroller, and the example of 8-bit microcontroller is Intel 8051, and Motorola is also manufacturing the same kind of chip, which is named as MC68HC11. The 16-bit microcontroller, here the arithmetic and logical unit perform the arithmetic and logical calculations based on a word, that means 16-bit at any instruction. So the microcontroller is known as 16-bit microcontroller. The internal bus width of this 16-bit microcontroller is a 16-bit wide, and the example for this 16-bit microcontroller are Intel is producing 8096 chip and Motorola is manufacturing MC68HC12. And some more companies are manufacturing 16-bit microcontroller. When come to the performance and computing capability, in the case of 16-bit, it has greater precision as compared to the 8-bit microcontroller. And in the case of 32-bit microcontroller, here the same thing, arithmetic and logical unit performs the calculation, that is arithmetic and logical operations on a double word, which means 32 bits. At any instruction, this operations can be performed, and this type of microcontroller is known as 32-bit microcontroller. The internal bus width for this type is 32-bit wide, and the Intel company and as well as Motorola and Atmel, all these companies are manufacturing these type of 32-bit microcontroller. And when compared to the 16-bit and 8-bit, the 16-bit microcontroller has more computing capability and performance speed, which enhance the greater precision. And here embedded and external memory microcontrollers. As embedded microcontroller means all the functional blocks are inbuilt together in a single chip. So this is known as embedded microcontroller. The special functional blocks such as program and data memory, input output port, serial communication, counters, timers and interrupt control logic, all these special functional blocks are embedded on a single chip. So this is known as embedded microcontroller. As in the case of external memory, it does not contain any functional blocks available on a chip. All the special functions should be interfaced with the chip. So it can also be named as a glue circuit. For example, 8031 in a microcontroller has no program memory on a chip, and this as an external memory microcontroller. And the microcontroller architectural features. There are two main categories in this architecture. One is Princeton or von Neumann, and the other one is Harvard architecture. These two architectures differ in the way the data and the programs are stored and accessed. Here, in the case of von Neumann architecture, it has a single data bus which is used to fetch both instruction and as well as data. So the program instruction and data are stored in a common main memory. So in this case, it first fetches an instruction and then it fetches the data to support the instruction. So the two separate fetches slow up the controller operation. So the von Neumann architecture main advantage is that simplifies the design, but it slows down the controller's operation. But in the case of Harvard architecture, it has a separate data bus and as well as instruction bus. So this allows execution to occur in parallel, and prefetch option is also available as in the case of executing on the data bus. So once the instruction is complete, the next instruction is ready to go. So this prefetch theoretically allows much faster execution than the von Neumann, but the expense is very complex when compared to von Neumann. Then this shows the pin configuration of 8051 microcontroller. It has a 40 pin dual inline package, and many of the pins have dual functions, and we will discuss about the pin configuration. So total pins are 40, and we have 16 address pins, 8 data pins and 2 interrupt pins, and for input output pins 32 pins are allotted, and as well as for the supply 2 pins are allotted. So in the case of architecture, here we have 34 8-bit registers and 2 16-bit registers. The stack size of the 8051 microcontroller is 128 bytes and the internal read-only memory size is 4 kilobytes. The internal random access memory size is 128 bytes. The external memory can be extended up to 128 kilobytes. Here we have 4 match flags, 2 timers and 4 parallel ports and 1 serial port. And the serial port is application can be very well applied in the case of universal asynchronous receiver transmitter. This shows the pin out function of the 8051 microcontroller. Here, the right side of the diagram, it shows the bidirectional port. We have 4 8-bit bidirectional ports in microcontroller 8051 and each port has 8 pins. These ports can be addressed as port 0, port 1, port 2 and port 3. So totally 32 pins are allotted for this pin function. And this RST, which shows the active high signal reset 8051, which is used to reset the microcontroller completely. So when it reset, the program counter reset to the initial stage, that is 000H. Then ALE, which is address latch enable, which is used to demultiplex the address and data. So the lower order address and the data can be demultiplexed using this latch. Then the next pin function is external access. It is completely concerns about the program memory. When the external access is high, the 8051 fetches instruction from the internal read-only memory within this address range, and if it is low, the 8051 fetches all instruction from the external read-only memory. Then PSEN, that is program status enable, which is used to read the strobe signal to the external memory. The active low signal is used to read the strobe signal to the external memory. XTAL1 and XTAL2. These are the 2 pins for connecting the crystal when internal oscillator is used. This XTAL1 is grounded and XTAL2 is used as a clock input. The frequency range for this microcontroller 8051 is 1.2 MHz to 12 MHz. This is the architectural block diagram for 8051 microcontroller. This has many special features and many registers are there. We will further discuss about the various registers and the special features about these registers. It consists of A register, that is accumulator, and B. These two are the 8-bit CPU register, and the 16-bit program counter and the data pointer, and 8-bit program status port, and 8-bit stack pointer, then internal read-only memory and internal random access memory, which has 128 bytes. Within the random access memory, the 3 ranges are categorized, that is 3 distinguished areas are there within the random access memory. The 3 distinguished areas are the register banks, then the 16 bytes of address level and the 80 bytes of general purpose area. Then 32 input and output pins, that is considered as the port pins. We have 4 ports in this 8051 microcontroller and 2 16-bit timers or counters, then full duplex serial data receiver and transmitter. And the several control registers are there, and the interrupt, 2 external and 3 interrupt sources are there, and oscillator and clock circuits. These are the specific features of 8051 architecture. And A and B CPU register. The 8051 contains 34 general purpose or working registers, out of which the accumulator and B register are highly used for any mathematical calculations. The accumulator register is the most versatile register among the 2 CPU register, and it is used for many operations such as arithmetic and logical operations. The A register is also used for all data transfer between the 8051 and as well as the external memory. That is, but the B register is used with A register. It cannot be used alone for any other function. Particularly B and A can be used for multiplication and division operation. B register has no other function than the A. Then the program counter. It is a 16-bit register, which means a 2-byte address which tells the 8051 where the next instruction to be executed. Here the program counter starts at 000H when 8051 initializes, and it's incremented every time after each instruction is to be executed. Program counter is not always incremented by 1. Based on the instruction what we are giving, it will get incremented by 2 or 3. This is the purpose of the program counter. And the data pointer DPTR is the 8051 special register, which is a user accessible, and it is a 16-bit register. It is meant for pointing the data. It is used by the 8051 to access external memory using the address indicated by the data pointer. Data pointer is the only 16-bit register available, and it is also used to store 2-byte values, which is segregated as DPH and DPL, that is DP higher order byte and data pointer lower order byte. As a 16-bit register, DPTR does not have a single internal address, but as in the case of two 8-bit register, DPH and DPL are each assigned as an address. The next register is program status word, which can be abbreviated as PSW. Within this PSW register, the flags in 8051 can be defined. Here in 8051 microcontroller, there are 4 math flags. The math flags are carry flag, auxiliary carry, overflow and parity. These are the 4 math flags used in the 8051 microcontroller, which is defined in this program status word register. This PSW register is an 8-bit register. Within this 8-bit, 4 bits are allotted to define the flags, and the 2 bits are allotted to select the register banks. So we will discuss about bit by bit. For first, the bit 0, that is for parity flag, which shows the parity of the register. If it is odd parity, means the result based on the arithmetic and logical calculation. If there is odd parity, means the flag will be set, otherwise it is 0. Then 1 is reserved for future purpose. Then overflow flag, which is used in arithmetic instruction. Then bit 3 and 4, that is RS0 and RS1, which is used to select the register bank. Within the internal random access memory, we have 4 register banks, that is bank 0, bank 1, bank 2, bank 3. And we can make use of any of the bank using the program. So to identify which bank should be selected, we can select these 2 bits, that is bit 3 and 4. So 00 shows us to select the register bank 0, and 01 select register bank 1, and 10 as well as select register bank 2, and 11 for bank 3. Then the bit 5 is for user flag, which is allotted for user to record any event in the microcontroller program. And the bit 6 is for auxiliary carry. This auxiliary carry can be set or reset based on the BCD arithmetic calculation. Then the bit 7 is carry flag. If there is any carry in the result of arithmetic and logical operation, this bit will be set, otherwise it is reset. Next, the main important thing in 8051 microcontrollers is internal memory. Because all this internal memory is inbuilt together within a single chip 8051. So the first thing we are going to discuss about the internal random access memory. The internal random access memory has 3 distinguished areas within the allotted location, that is from 00 to 7FH. So the first distinguished area is we have 4 banks of register within the 8051. Then the second distinguished area is a bit addressable area, and the third distinguished area is a general purpose area, which is used for any type of instruction and as well as to write the program. So the first distinguished area is the 4 register banks, and these can be considered as the working register. Within each bank of registers, within each bank, we have 8 registers, that can be addressed as R0 to R7. So all the bank, that is for bank 0, we have the specific location R0 to R7, that is from 00 to 07. And for the bank 1, we have the specific location for R0 to R7, that can be addressed as 08 to 0F. And for the bank 2 and as well as for the bank 3. So each bank consists of 8 working register within the bank itself. And beyond the bank register, the area which is located as 20 to 2F, which is known as bit addressable area. And this bit addressable area is used for any type of calculation and any type of storage. Any result can be stored within this area. And beyond the 2F region, that is from the location 30 to 7F, it is considered as the general purpose area. The size of this area is totally 8 bits. So the internal RAM size is 128 bytes. This 128 bytes can be categorized within these 3 distinguished areas. All the special features are given in this description. Then here, the one more special feature in the internal RAM itself, stack and the stack pointer. Here the stack is a section of the internal random access memory used by the central processing unit to store the information temporarily. And this information, either it be a data or it could be a data or it may be address. So this CPU needs this storage area since there are only limited number of registers. So the register to access the stack is known as the stack pointer register, that can be abbreviated as SP. This stack pointer register is also a 8-bit register, and this can be addressed within the special function register area with the address 81H. And you can point an address location from 00 to FFH. Here, stack pointer is generally used to hold the address of the top of the stack. The address held in the stack pointer is in the location in the internal random access memory where the last byte of the data was stored by the stack operation. This register can also be used to hold one 8-bit address at a time, which is actually the memory location at the top of the stack. The stack pointer is initialized to the value of 07 when the 8051 microcontroller is reset. This is the example for the stack operation. This block diagram shows this block diagram shows here the automatic increment while storing the data on the stack. First, the data 07 is stored and it gets incremented. Then, while retrieving the data, what we have stored, automatically it gets decremented by each location. So this block diagram explains about the stack operation. Generally, stack referred as last in, first out memory. So the data which we have stored last can be retrieved first. So this block diagram explains the same. Next memory in this 8051 is internal read-only memory. Here we can see the two set of diagram. One, the external access pin from the pin configuration 8051 is connected to VCC, and the next one is the external access pin when it is grounded. The two possible cases are there when we discuss about the internal read-only memory. So if it is connected to VCC means if EA is equal to 1, right, then the first 4 kilobytes of read-only memory is internal and the remaining can be considered as the external memory. If it is connected to ground, that is if EA equal to 0, then the entire 64 kilobytes of read-only memory is completely external. So the read-only memory block which is used to store the program, that is in the program memory. The 4 kilobytes of read-only memory of built-in program memory, that is from the address range 0000H to 0FFFH. And if it exceeds the internal ROM, that is internal read-only memory capacity exceeds, this will cause the 8051 to automatically fetch the bytes from the external program memory. The external program memory can be addressed as 00002 FFFH. This can be accessed, the two type of can be accessed with the pin configuration, that is with the pin external access from 8051 pin configuration. Oscillator and clock circuit. In 8051 there is a circuitry that generates the clock pulses by which all the internal operations can be synchronized. Here we have two pins, that is pin XL81 and XL82, which are provided for connecting a resonant network to form an oscillator. The oscillator formed by crystal capacitor generate a pulse at the frequency of the crystal. The smallest interval of time to accomplish any simple instruction is known as mission cycle, and this one mission cycle is made up of 6 states. So 2 oscillator pulses define each state. Program instruction may require 1, 2 or 4 mission cycles according to the instruction what we are writing, so it can be executed. This shows the pin configuration of 8051 and how the two XTAL1, XL81 and 2 can be connected with the crystal resonator, and the second diagram shows the 6 pulse state. So the two that is it explains about the mission cycle. So it comprises of a 6 state, so 2 oscillator pulses defines each state. And this is the main thing in the 8051 microcontroller, special function register. It can be abbreviated as SFR. Many of the registers are 8-bit register, and it has a permanent address, that is internal address, which can be named as internal RAM address, but it is not actually from the random access memory. But these are the register which can be addressed, and there is a purpose, there is a special purpose for each registers, like internal random access memory. And the first register is accumulator. The internal address for this accumulator is E0 and a B register, and the data pointer can be segregated as a DPH and DPL, which is addressed as 83 and 82, and the interrupt registers are interrupt enable control and interrupt priority. And we have 4 ports, P0, P1, P2, P3, and these ports can also be addressed as a register with this particular internal address, that is 80, 90, A0 and B0. And the power control and program status word, it is also 8-bit register, and it is addressed as 87 and D0, and SCON is known as a serial port control, and SBUF is known as serial port data buffer. These two registers can be combined together for any serial communication purpose, which is mainly used for universal asynchronous receiver and transmitter operation. And the stack pointer, which is abbreviated as SP, which has the internal address 81. And for the timer and counter purpose, we have totally 6 registers are there. That is, the first one is timer TMOD, which is the timer and counter mode control, and the timer counter control, which is abbreviated as TCON, and TL0, TL1. That is, we have 2 timer registers apart from that is timer 0 and timer 1. These 2 timer registers are a 16-bit register which can be segregated as a 2 8-bit register, which is addressed as TL0, TL1 and TH0 and TH1. These are the 2 timer registers with the internal address 8A, 8C, 8B and 8D. And some many of the special function, in the special function registers, all the registers are addressed with the internal address, but some of the registers are bit addressable and some of the registers are byte addressable, which shows us, this diagram shows us the registers which are bit addressable and the register which are byte addressable. Thank you.